Difficulties. Briefly, this is a discussion of the Alachua County Arduino Winkeyer. And this is a great little project, especially if you've got some Morse code operators in your group or anybody who wants to learn how to do it. Not only is it just a regular old keyer, which is not all that special, but what its real specialty is it can connect to logging programs like the N3FJP system, and it can send canned text during contests or field days without having any messed up, jerky, jumpy code because of Windows. It's a standalone hardware piece of equipment that will do a much better job of sending Morse code. You can do some of this directly from a lot of radios, but you cannot get those radios to format a full message, including the call sign of the other person. And you cannot get those to make it really easy for you to change speed right on the front panel with a hard control. So the Winkeyer is really, really nice. We learned about it from a local expert. And after I figured out how this works, it just dramatically improves your performance in contests. Your fingers stay right on the keyboard. In an entire several hours of operating, I only have to send a few things with the paddle. Most things are sent directly with Winkeyer. This is the setup page that's in N3FJP. It's not the entire setup sequence, but it's part of it. And it shows you how you can configure the canned text. The $sign here refers to the other person's call sign. So the typical sequence is you call CQ with F1. And then when someone answers you, you immediately enter their call sign right here. That immediately stops any further CQ activity. You then press F2 with your keypad, not with this on-screen stuff. And it will automatically send back a message saying, so-and-so, here's our exchange. That person gives you their exchange, and then you hit F4. It's not programmed properly in this little list, but when I'm in a contest, it will answer and say QSL, QRZ, who's calling me, and go for the next contact. So with just a F1, F3, F4, F3, F4, F2, F3, F4, I can run entire strings of contacts without ever having to send anything. So there's a commercial product that's on the market. Steve, K1EL, sells various versions of the Winkeyer. They're very nice, and he sells out always before major contests. And if you're waiting to the last minute, you simply won't be able to get one because everybody has bought out his entire stock. It's a nice product. It works really well. But what Steve did that was more beneficial to the community was he created a protocol. And his protocol is what N3FJP and N1MM and all the major programs use. I think there may even be POTA loggers that use the same protocol, and that's what standardized the connection to control these external keyers. So with his standardized program, you can buy any Winkeyer and it will work. But that also means that we can simulate a Winkeyer and have our own homebrew version that works just as well. A problem with Steve's product for some of us is he's built for modern transceivers. He's not built for older Heathkits that have high negative voltage keying, like negative 70 volts. That will blow out his software and things, his hardware and his device. So that was one of the reasons I wanted to build my own. When you're using any of these Winkeyers with his protocol, it's very important in our experience that you go into Windows, go into Device Manager, go into the port that you're going to use, and change that bits per second to 1200. I don't completely understand the ins and outs of why this can't be set automatically, but your life is much better if you set this to 1200 so it stays there, and that makes his product work an awful lot better. Arthur Good, K3NG, Anthony Good, many years ago wrote freely available code that simulates the Winkeyer on a simple Arduino. He has an astonishing amount of well-documented code on this site. I don't use nearly all of it because I use Arduino Nanos and it just all won't fit. But there are commercial products out on the market. This is an example of one that you can purchase that use his code and use Steve's protocol. And I presume that they work quite well and that they're made reasonably well and you could get good service out of them. The problem for me was that doesn't teach our people things that I want them to learn. So although a lot of our people don't really do Morse code, they don't mind building things just because they learn so much. So instead of buying an off-the-shelf Winkeyer, at the North Florida Amateur Radio Club, we wanted to give our volunteers a chance to build this and learn in the process. And of course, this is part of FCC 97.1, as I constantly point out. We're not just supposed to be button pushers, we're actually supposed to be advancing skills and communications and technical phases and advancing the reservoir of people who are trained and able to do things. So here's a couple of homebrew Winkeyers that I built, and some of these have modifications that allow me to key a high voltage Heathkit, ancient vacuum tube, EMP proof kind of radio, which you can't really get with the commercial versions. So this is a really nice project for a ham club. I have a printed circuit board and you can get the Gerbers for that and have them built for a couple of dollars per board. There's no tricky RF wiring. This is all done at baseband. It turns out this double-sided printed circuit board, so it's kind of got its own shielding. It's not very RF sensitive. It can be powered either by 12 volts or by just connecting it to the computer through a USB cable will also power it. There are relatively few components. What it emphasizes is lots of connectors and lots of connections between the radio, the Winkeyer, the straight key, and other things. And that actually is really good for ham radio operators because they're often kind of weak as to what does this connection do and how many wires are in it and what does each wire do and what pins does it use. So this kind of a project, excuse me, gives them a chance to practice that kind of stuff. This is the base schematic of a Winkeyer, and this is it is so simple. This is the Arduino, in our case, an Arduino Nano. This is a real simple display, and in our case, it's a 2-line LCD display. They go for about $5. The Arduinos go for about $5 also. We have a polarity protected power supply here with a 3-terminal regulator. You have a connector that can go to a speaker and give you a side tone. You have a dash input, a dot input, and you have a couple of different outputs. So you can have a keyed line output. You can also have a push to talk output. If you want, you can have an LED that lets you know when you're transmitting, and you can have multiple command buttons. You can store canned text right in the Arduino. I don't do this. It doesn't fit my use model, but it will work. And when I'm not working with N3FJP, sometimes I'll program in a CQ and just use that. It also has what's called the command button, which is what's used to switch you from operate mode into I want to update mode. We added a little simple transistor, a 2N3904, to control a read relay to handle the negative voltage Heathkit type radios. The side tone output is pretty simple. It's just basically a square wave, not the most melodious sound. A lot of times you've also got sound coming from your radio, and so you don't really need this in the first place. And as I mentioned, it can be powered either of two ways, whichever, but you can connect them both, it doesn't matter. Whichever one produces the highest voltage will provide all the power. This is a picture of the double-sided printed circuit board. And for my group, what I did was I had the silk screen include dividers that break it up into sections so they can actually kind of see what's going on and what each section does. Because Some of it's optional. You don't necessarily need it. The base system doesn't require it to operate. So there's a few extra doodads on this board than what you really need. So here are the sections marked out so you could see them more clearly. Got the Arduino, the paddle input, the display system, which is actually optional. Printer cable, if you want to try to power it that way, optional push to talk input, output. The keyer output, side tone output, optional 12-volt supply, optional second relay if you really want to have a second relay. So you can do a lot of things with this. After I built it and actually took it to one of my vacuum tube radios, I discovered an unexpected event. The little reed relay contacts actually sort of welded together. And that was because when they closed, this little capacitor, RF bypass, really delivered a jolt of current to those contacts. That was not good. By adding a little resistor in series, small modification to the printed circuit board, that fixed that problem. And now it keys my Heathkit transceivers just fine, and they do nice Morse code. All of this information is available on our webpage, and so you can get there, and this is included in the talk. I'll try to let this go there, and it will load up the page from our webpage, and this is quite a long manual that shows how it's built and has a bunch of sections. Here's the features, how it works, because that's a little complicated to some people. And then it goes into build this part first, build this part next. So it breaks it down into what you need to build in little bitty bites. And so our people did reasonably well with this. What we found generally is we will put a example in front of them and also have this manual. And between the example and the manual, they can generally build things. Packaging most projects is one of the harder parts. So we also wrote a packaging manual, which explains how you actually get this in a box. A lot of our people are not very familiar with any kind of packaging. So they don't know much about drilling holes, especially how to make a square hole and what standoffs are and ways to wire things. It's all very confusing to some of them. So we kind of provided some information on how you'd want to do that. So this is an example of one of the versions. You can see the Arduino Nano right here. You can see the 3-terminal regulator right here. This is the paddle input, and I used real simple phono plug outputs because Steve uses the exact same thing on his commercial keyer, and so the cables for this, Steve makes them and sells them if you don't know how to build them yourself. The Arduino is on this side, and the display actually is mounted on the other side, which saves a lot of printed circuit board space for me. This is part of our crew busy building one of these, and we put some cardboard, undo a box and put cardboard all over the table, and then they go to work just soldering and building, and they have a great time doing these things. We have a range of abilities in our group, from folks who are pretty savvy to folks who are sort of having a problem, but they all manage to get it done. This acquaints them with brass standoffs to mount the printed circuit board, helps them begin to understand some of the connector types. We have a template that shows you where to drill the holes. We use a Dremel rotary cutter to make the square openings, and then we put a bezel on top of that to cover up some of our work. They learn how to mount potentiometers for the speed. This is one of our volunteers actually with safety glasses on, using the Dremel to cut what's going to end up being a square hole in my extremely messy, tiny hardware shop. But this is something our team, nobody had ever done this. So they had no clue how to do this, and they found they could actually do it. Now, when you're operating this keyer, it has two modes, command and and plain old operating. To enter the command mode, you do a brief press on the command button and it chirps at you. And if you have a screen connected, it tells you it's entered command codes. I could not use the entire set of the commands, but I managed to use a good number of his commands. So in my version, you're able to fill up memory number 1 with a message, memory number 2, memory number 3. If you get your paddle wired backwards, you can use the N command to swap the paddles. You can use various where you want the side tone to go, no side tone at all, only have a side tone when I send from the paddle, or have a side tone every time anything gets sent from the computer or the paddle. It has automatic memory repeat, and you can set that memory repeat for how many seconds. So for instance, I often have a 3-second, 4-second delay between CQs. And then it has a tune mode that's really interesting. Press one of the 2 paddle keys and it'll just send for as long as you hold it down. Press the other and it stays in tune. So if you need to walk a bit to adjust something, you can do it. So it's actually kind of nice. We already kind of went through this. This is setting up the Winkeyer, and I've pushed the button to go in to configure the Winkeyer. Now you open the port to the Winkeyer and it will tell you if it gets it open. And you can set various settings, which the most important is, do you want to key port 1 or port 2? So if you've got 2 different radios connected to this, you can switch which one you want to key, and you can select so that speed is either controlled here or is controlled by the potentiometer. It does various kinds of keyer modes, iambic A and B, but I'm not bright enough to know those. So I just leave it in iambic B, and I do very simple Morse code, and I still made 300 plus contacts last year, so it works. The next part of the deal is that paddles are very expensive. I don't know if you've noticed this, but that's as much as some radios cost. So I have a Venture and I like it a lot, but it was given to me. So we wondered, well, could we make paddles? Is there any way we could make paddles that would be cheaper, so some of our people who are just getting started could have a cheap paddle and not have to, fork out a whole bunch of money to do all this stuff? What we discovered was that solid state inputs from the Arduino are not very picky. They work fine with a very simple screw to metal contact closure. You don't have to have fancy iridium or silver or gold plated contacts or anything. They work really fine with just what you buy in the hardware store. So we were able to build paddles by simply using right angle brackets, which you can get at a hardware store. You can order on Amazon. And there's this zinc plated steel tie plate that sells for 88 cents at Home Depot. And it's just perfect for, oops, I didn't want to go there. Well, I guess we're going there anyway. That's where Home Depot sells it. And I don't want to sign in. I guess this picture will eventually show up, but it's just a piece of steel. And then here's where I wanted to go. This is what it looks like. So this is a bird's eye view of a very simple paddle. And I'm not using the entire length of the tie plate. It turns out that gets too flimsy, too flexible. And all I've done is support it here with 2 screws and an angle bracket. And here I have a screw for one side and a screw for the other side on different angle brackets. And I have about 6 inches worth of the whole thing that works for the paddle. And I put a knob on one end to be fancy. And all you do is adjust these contacts until it's the distance that you like, and you're done. Some people like the distance kind of wide, and some people like the distance kind of not so wide, which is the way I like it. This is one of our volunteers. This was his keyer before he got it in a box, and he built this paddle to go with it. and doggone it, it works. So, we were able to build these things in the range of $25, and we were able to build these in the range of $7. So it's like dirt cheap. So what this allowed me to do, I looked at this and I said, I have trouble carrying a paddle with me when I go to North Carolina to our vacation home, or if I go to a park. It's always a problem. I'm scared I'm gonna break the paddle. And all I did was move my 7300 over a bit in my homemade Go box, and I was able to fit a homemade paddle right here in this space for $7. And I have my own built-in Morse code paddle on the radio. Yeah, I can use this directly into the 7300 because it's got paddle input, or if I really need it, I can bring along the Winkeyer. But either way, this just ended up being a really nice project for our group. And even though a lot of our people can't read Morse code, they have a lot of fun with it. We have taken this to public exhibitions, like the Red Cross had this thing, the local blood place, and kids show up. We can put one of these cheap paddles out there and they can just send junk with it. If it turns out they send a real character, the Winkeyer will show what character they really sent. And so they can have fun trying to see what they sent. And if they tear the $7 paddle up, it's no big deal. Readjust the screws, bend the plate kind of straight again, and you're ready to go. So it's been a very nice project for our group. It's kind of a niche project, but if you're looking for something to do with your group and you got some CW operators and you want to give them a better chance to do better in field day or other contests, this works out really well. That's the presentation. I can stop and answer questions.
Any questions from anyone? I was putting sweetener in my tea. I've learned to hold on to this chair before you sit in it, or else it rolls that way and I go that way. So, say that again. I'm sorry.
All of their club projects they've done on their website?
Gordon, are all the projects you mentioned on the, I think it's the North Florida Radio Club website?
Yeah, just about everything that we've ever done is on here somewhere. Let me show you where.
Yeah, go ahead and show them the link to the website so it'll go in the video.
nf4rc.club. We have an older site, but one of our guys was appalled at my older site, and so he fixed us up this really fancy new site. So under here, we've got a whole slew of things, and this one is the educational articles. And here, I'm gonna make this a little smaller because the Zoom is in my way.
Yeah, nice WordPress layout. I like it.
Well, that was my volunteer. I didn't do this. But we've just got, zillions of articles and projects that we've done, lab and lunches that we've been doing for several years, tech night talks that we've been doing for 3 years. So there's just a lot of stuff here that will probably help you out. For instance, I had to rebuild a diesel generator, and so there's the information on how that particular diesel works. I had to set the timing for the diesel pump. Never did that before. Learned how to do that. Digital VFO. We built a digital VFO to control a Heathkit SB100, gave it digital computer control, and it worked. It's pretty amazing what you can do. And there's the digital VFO for a Heathkit, built in a bread box from a thrift store, and it worked fine. Feed it in the external VFO input, and it just works great. So go ahead.
Good enclosures are around Christmas time. The Dollar Tree has those metal cookie tins, $1 a piece. In October, November, December, they make great enclosures, and they're ferrous metal. And then you take the lid off of it to work on the inside and mount your controls on the sides. You got places for connectors on the back and controls on the front, and they are ferrous metal controllers. If you best want to pitch it and get another one to start over. So yeah, but I try to buy some of those every year just for projects during the rest of the year.
So this kit is a school radio kit that I did with sixth graders, and it has every portion of how to build. It's a direct
Wow.
conversion computer controlled receiver, and it's dirt cheap simple, and it actually works. And the Gerbers for the printed circuit boards are included, and this is the balanced mixer. Very few people have actually wound toroids and built their own ring diode detector, which will work at just about any frequency. And this taught the kids how to wind that transformer themselves. And there's one that I'm teaching.
There's a
sixth,
toroid
seventh,
right
eighth
there.
graders how to build transformers. And you just, all this stuff is out there. Some of it may fit what you want to do, some of it may not, but it's all available for you.
What's interesting is when you wind a toroid, that the outside of it is no bigger than that pin right there. That's when it gets real challenging. I did, but when I was building, I need to go back and finish it. The Soft Rock RXTX ensemble transceiver, a whole bunch of toroids about that size. And winding those transformers was quite interesting.
Yeah. We also have the antenna multiplexers that we've built and the bandpass filters that we built. They should be on here somewhere. We've done a lot of work on how to get more people onto the same antenna. So we generally put 3 people on a beam antenna, and we can put multiple people on a simple wire antenna, have it do multiple transmitters simultaneously.